Name node is the master and it will store all your metadata, and your actual data will go on data nodes, right? So this is what we discussed yesterday. So for people who are joining today, so what I explained yesterday was what happens in traditional file systems, whether it's Linux, Windows. Whenever I write any data, the metadata and your actual data resides within the same system, right? For example, I write a file 1, the metadata, which is, let's say, the file allocation table we called fat in Windows or inodes in Linux, they will be sitting in the same system as your data. But in the case of Hadoop, your metadata will be sitting on a separate node. We called it as name node, right? And your actual data will go on data nodes. So yesterday we looked at what name node does, right? So name node stores two types of metadata, right? So what are the two types of metadata? Can anybody recall from yesterday's session? Let me clear the screen and we will start, because this is very important to understand and to build your base for your entire course, right? If you have any questions, please feel free to ask. So let me ask, what are the two types of metadata name node has from yesterday's class? Okay, so Raiguru is saying bitmap, Pawan is saying fs image and edits. Okay, right? So my question was, what are the two types of metadata we have, right? So two types of metadata are, one is the file metadata, another is your bitmap metadata, right? There are two metadatas. So it is, I'm not talking about what files we have, right? I'm not talking about whether I have, let's say, a journal or an fs image. I'm talking about two types of metadata which a name node has. So what are that, right? So very important to understand this. Let me start that once again today. So as I said, let's say I have a file1.txt. What will be a metadata of this file? Who is the owner? What are the permissions of this file? What is the timestamp? What is the size of the file? What will be the replication, right? I will come to this later. You can forget this for the time being. Then it will say what all blocks a file has. Means it will tell me a mapping saying, okay, this file has these blocks which are B1, B2, B7. This is one metadata. We called it as file metadata. This is always persisted to disk. Means whenever you shut down your node, your master node, it will be persisted to your disk, and it is also occasionally also being updated, constantly flushed to the disk, because if we start keep it only in the memory and if your machine fails, you will lose data, right? Your file system will be corrupt. So it will always keep on going into a journal which is edits, and that edits journal is always committed into fs image, right? So these are the two files which we will see a name node will have. So it will be persisted on disk. But another metadata it will have will be bitmap. What is bitmap? It is a mapping between block and data nodes. It will say block B1 is on data node 1, block B2, let's say, is on data node 3, right? Slave 3, right? So this metadata is never stored on disk. It will always be in the memory of the name node, right? And very important to understand this, right? So I will explain you a lot of things which are related to this, why this was done that way. So now This is what it is explaining you. Two types of metadata: file metadata and the mapping between the blocks and your data nodes. So the key points which you should remember is only the file system metadata is persisted to disk. The mapping between the blocks and the data node is never persisted to disk, right? Every time data node starts, it will advertise what blocks I have, and name node will build the bitmap. So name node will say, I have received block B1, it has come from data node 1. It will map it, right? So the bitmap will be something like this. So it will say block 1 is on data node 1, 2 and 4. Why? Because each block is replicated 3 times, right? So I will come to replication part, but for the time being you will think a bitmap will be something like that. Each block will be mapping to which data node it is on. So let's say, so yesterday I kind of give you a homework asking you to think and come out with an answer when I said the size of your cluster will depend upon this amount of memory you have on your name node. How? Right? So I explained you a little bit yesterday that everything in Hadoop is an object, and to store or represent that object, it needs some memory, right? It will acquire some memory. So obviously, memory will be the limiting factor, how many objects I can store in a memory at a given time. For example, let's say if I have a data node with 1 TB disk size, and my HDFS block size is 64 MB, right? Which we have explained yesterday, but I will again go into this detail today. So it will have these many blocks. So these many blocks will be advertised to the name node. So name node will know data node 1 has capacity 1 TB and it has these many blocks. Now, name node keeps the entire metadata namespace, right? What is namespace? Namespace is simply a file structure, file system data structure, always in the memory while it is running, and it will always at the same time it will keep on persisting it to a journal and to the disk. Name node records the changes in the HDFS in a journal, right? Which is called edits, similar to a MySQL bin, right? Whatever change we do, it writes into a journal, then it is committed to a database. The location of the block replicas are not part of the persistence checkpoint, right? As I said, name node will not know, will not persistently store the mapping between a block and data node. So these are the two files a name node will have: fs image and an edits. The inodes and the list of blocks that define the metadata of the name system is called an image, right? So let's say somebody says, what is an fs image? Fs stands for file system image. So it is simply an inode structure, right, for your name node. So each transaction we do will be recorded in a file called edits, and there will be a file fs image which will never be changed by the name node unless you reboot the machine or you do a checkpointing process, right? So we'll see what is that checkpointing process. So thing is, let's say if my cluster is up and running and I keep on writing data, my edit file will keep on growing, means my journal will keep on growing, right? And it will only commit to fs image whenever I restart or I do a checkpointing. So let me explain you this, what this statement means. Okay, let me clear the screen now. Let's say my Hadoop cluster is up and running and I have a file which is edits, it's a journal, similar to a bin log, and I have an fs image, right? So fs image is the image with which my name node will start very first time, and that fs image will not change. Why? Because whatever writes, deletions, whatever I do, they do not go into fs image, they all go into an edits journal. So this journal will keep on growing, right? It will keep on growing during the life of the cluster. So let's say it might grow very big, 10 gigabytes, let's say, right? So what will happen the next time when I restart my name node, right? What will happen? It will try to commit this journal into the fs image file. So name node will take longer time to start up because it has to empty this file. It will empty this file into this file, right? But unlike database, what databases do? You write into a bin log journal, a sleeping daemon will wake at the background, take whatever was in bin log, commit to the database. But here it is not the case. Edits will never be committed to fs image unless and until you restart your name node or you do checkpointing. So checkpointing is a process of emptying edits journal to fs image, right? So how checkpointing happens, we'll see that, right? So checkpointing is a process of committing your edits to fs image. So this is what it is saying. So whenever a name node is started, it will read fs image, read edits, and commit the edits. Whatever changes are in edit, maybe a block addition, deletion, file deletion, whatever, it will do that changes to fs image, commit it, empty the edit journal, and start with the new fs image. So fs image will never be modified during the running time of the name node, right? Right. So this statement, for the time being, you just take this statement that it will not be modified during the running time of the name node unless and until checkpointing happens, right? So I will tell you what checkpointing it and how it happens. So now the key points here is, as we discussed yesterday, HDFS block size by default is 64 megabytes in Hadoop 1. In Hadoop 2, it is 128 MB, right? So whenever I write a file to HDFS, it will be split similar to any file system, right? For example, even if we write a file to Linux or Windows or whatever, I write a file, how small it might be, let's say 1 kilobyte. It will be split into smaller blocks depending upon the block size of your file system. So in Linux, ext3, ext4, whatever we use, the maximum block size could be 4 kilobytes, right? 4 kilobytes. So similarly in Hadoop, this has become 64 MB, right? So what will happen? Any file which I write to HDFS, means to Hadoop, will be split into blocks of 64 MB, right? So let's say if I have a file whose size is 128 MB, that file will be split into two blocks on HDFS. Every block is replicated 3 times by default, right? So I do not need to put any kind of a RAID in a system, means redundant array of inexpensive disk. I do not need to mirror my disk. So whatever data I put will go at 3 places. So let's say I write a file which is split into two blocks, block 1, block 2. Block 1 will be replicated at 3 places, means it will be at 3 data nodes. Block 2 will again be at 3 places. For example, let's say I have a file called foo. it has, let's say, block 1, 2 and 4. So block 1 will be on this node, right? Here the replication has been shown as 2, right? But the by default replication will be 3. So block 2 goes here, goes here, right? It will never be replicated on the same node, right? It does not mean, let's say a system has 4 hard drives, one block will go in hard drive 1 and a copy will go in the another hard drive. No, it will always go on another system, so that if that node fails, I still have data somewhere else. So replication is of what, right? It is very important to understand. Replication is of what? Replication is of data, not metadata, right? Some people say or confuse that the metadata of the name node is also replicated. No, I have a name node which is master, which is holding metadata. I have data nodes, let's say 4 data nodes. I write 2 blocks, let's say block 1, block 2 to HDFS. The metadata of this will be written on name node. Let's say it will say file1.txt only once. It is never replicated. Let's say name node says block 1 goes here, block 2 goes here. Then each block will be replicated thrice, means it will be at 3 places. One is already here, it will say, let's say put it here, right? It will say, okay, let me put it here. Similarly 2, it will put it here, let's say it will put it here. So each block is at 3 places. So if this fails, I still have data. If this fails, I still have data, because it is at 3 places, right? But if this fails, it is an outage. So name node is a single point of failure, right? In Hadoop 1, right, we are starting with Hadoop 1. There is only one master. If it fails, my cluster is down. Although my data is there, blocks are there, but metadata is here. I have no way to reach it, right? So my cluster is down. Okay, so Shiva is asking, if I have 5 data nodes, for example, it will replicate to 5. No, right? No, right? So the point will be, by default replication is 3, means irrespective of the size of your cluster, it will be only replicated maximum 3 times, because it does not make sense. Let's say if I have 100 node cluster and if I replicate data 100 times, I will run out of space, right? So there's no point of running a 100 node cluster, right? So what will happen? By default replication is 3. Let's say if I have only 2 nodes, 2 data nodes in my cluster, and I do not change the replication, which I can change, but by default it is 3. Whenever I start my Hadoop cluster, replication will be 3, irrespective of the number of nodes I have. Let's say if the number of nodes, let's say denote by n, is less than the replication factor, means the number of data nodes I have in my cluster are less than the replication factor, it will throw me a warning in the messages, right? If you do fsck, right, similar to a file system check on name node, it will tell me a warning saying under replicated block. So it will copy one block on this node, another block on this node, but third block, it has no other data node to copy. So if I go and look into the log and run fsck, it will keep on giving warning saying under replicated blocks. Why under replicated blocks? I have set replication 3. I have set name node to replicate 3 times, but I have only 2. I have given it only 2 data nodes. So it will keep on giving warning. But if I have more data nodes, still maximum it will be 3 times. I can change it, right? There's a parameter I will tell you, right? There's a parameter which I can control, which controls how many times each block will be replicated. So whatever file we write, it will be split. So it will be split like this. I have a file, It will be split into smaller blocks, each block 64 MB, and written to data nodes. And that change will be recorded by your name node in the memory, and also persisted to edit logs, and edit logs rolls back into fs image, right? Edit log is rolled into fs image during checkpointing. So now coming to the discussion which I said I was doing yesterday, and I gave you a kind of a homework, how I decide the size of my cluster, or how can I say how big my cluster could be, right? So this is I explained to you yesterday. So if I have a file whose size is 128 MB and HDFS block size is 64 MB, means the HDFS file system block size is 64 MB, the file I write will be split into two blocks, right? So now, as I said, in Hadoop, everything is an object because it is based on Java object-oriented concepts. Hadoop, the native code of Hadoop is Java. Everything is an object. Every file I write to Hadoop is an object. Every directory I create is an object. Every block which is created on Hadoop file system is an object. Each object occupies 150 bytes of memory in the name node to represent it. Means the metadata to represent one object is 150 bytes. So now I have two blocks. One block 150 bytes, so two blocks 300 bytes plus one for the file name itself, so I have 450 bytes. So if I want to write a file file1.txt on a HDFS file system, its size will be 450 bytes in the memory of the name node, correct? So I will divide the memory I have available on my name node by the block size of my Hadoop cluster. It will decide how many blocks I can have. That will decide the size of my Hadoop cluster, right? So now here, this size which I'm talking about, it's only for one replica. As I said, each block is also replicated 3 times, right? Total replica is 3, means each block is at 2 more places. So this number is only for one replica, correct? So what is added to this is 16 bytes, right? So file name will not change, right? Because now what it will do, let's say if a block is replicated 3 times and I have a file1.txt, now it is replicated, what it will say, one object will be for it whose size is 150 bytes. Now it will say I have block A, block B2, right? 150 for this, 150 for this. These two blocks are at 2 more places. This block is at 2 more places. This block is at 2 more places. But all are pointed by one file name. So this takes only 16 bytes, right? Only 16 bytes.